in question number 2.30, it is given that a spherical capacitor is there where the inner sphere having radius 12 centimeter and outer sphere having radius 13 centimeter, and the gap between the two spheres are filled with dielectric constant having dielectric constant 32, and this much amount of charge is induced on the inner sphere and the outer sphere is earthed, means it is connected to earth, right? So as we know the concept of earth, the earth has always zero potential. If we connect anything to the earth, the potential of this sphere becomes zero. So the potential on the outer sphere becomes zero because it is earthed. It is connected to earth. So the potential on the outer sphere is always what? Zero. Now in first question, they asked find the capacitance of the given capacitor. As we know the formula, in the previous question we already derived the formula of spherical capacitor, that is equal to 4 pi epsilon naught R1 R2 divided by R1 minus R2. But here the gap between the two spheres is filled with dielectric, so it becomes k times. As we know the effect of dielectric insertion, if you insert a dielectric between two conductors, then the capacitance becomes k times. So you have to multiply this formula with k. So if you substitute all values, you will get the answer of this capacitance, right? Now in second question they asked the potential on the inner sphere. Now what is the formula of capacitance? Magnitude of charge divided by potential difference. Potential difference means potential on sphere having positive charge and potential on sphere having negative charge. The positive charge is on the inner sphere, so in place of V plus we are writing Vi, right? And in place of V minus we are writing outer sphere, Vo. The outer sphere is having zero charge because it is connected to earth. So the potential, not zero charge, the potential on the outer sphere is equal to what? Zero. See, the outer sphere having some thickness. If you induce the plus q charge on the outer sphere, then what happens? On the inner surface of outer sphere, some negative q charge is induced and some positive q charge is induced on the outer surface. But if you connect this with earth, then what happens? The negative charge comes from earth to this surface and the total charge on the outer surface becomes zero, and the negative charge is induced on the inner surface of this sphere. So this inner surface having negative q charge and the outer surface of this inner sphere having positive q charge. So this is capacitor having both same charge, plus q and minus q. But due to earthing, the potential on the outer sphere is always what? Zero. So the potential on inner sphere is equal to what? Q by C. The q is given, charge on the inner sphere is given, and substitute the value of capacitance, you will get the potential on the inner sphere. Now in the third question they asked compare the capacitance of this capacitor with that of an isolated sphere. Isolated sphere means only single sphere is there. If you substitute this much amount of charge on this sphere, then what is the capacitance of this capacitor? As we know, for a single spherical capacitor, for a capacitance of single sphere is equal to 4 pi epsilon naught R. We already derived this formula in our theory portion. So find the capacitance of this isolated sphere, then you will get this answer. This question shows you that when you use single sphere, your capacitance is in 10 power minus 11. But when you are using two spheres, means when you are using two conductors, your capacitance becomes 10 power minus 9, means it is increasing. So as I already explained in the theory portion, when you use two conductors to form a capacitor, the capacitance will increase compared to a single conductor. So for that this question is given to understand that concept.